Welcome to this course on mechanical measurement and controls. In this lecture, we are going to start with classification of measuring instruments. Measuring instrument can be classified as mechanical, electrical, and electronics instruments. We can also classify them as active and passive instruments, analog and digital instruments, primary and secondary instruments, monitoring and control instruments. Now let's start with mechanical instruments. Mechanical instruments are used in static and stable condition. For example, we can use this micrometer for measurement of diameter of a wire. Similarly, we can use this pressure gauge for measurement of pressure that is varying gradually, maybe increasing or decreasing. But just think of a pressure which is fluctuating. Now what is going to happen with this pressure gauge? As the input quantity, that is pressure we are trying to measure, is fluctuating, and we are getting that information with the help of this pointer. So as the input is fluctuating, this pointer is also going to fluctuate. And now if operator want to read the pressure from this pointer, he or she may not be able to get that at a given time because of the fluctuation. Now why that is happening? It is happening with the mass element that we are having in mechanical measuring instrument. Now we know that mass is having its own resistance, or we can say that inertia. So whenever we want to put mass in motion, we need to apply additional force, and whenever it is in motion we want to stop it, so we need to apply additional force to stop it. And because of that, these mechanical instruments are not good in dynamic and transient condition because of this inertia problem. And also because of the mass, we may have problem of noise also. Next is electrical instruments. Electrical instruments give us more rapid response as compared to mechanical instrument. For example, we are having an ammeter which we can use for measurement of current. Similarly, we are having a wattmeter that we can use for measurement of power. Now these electrical instruments are used for measurement of electrical quantities or related quantities, but they are also suffering from the same drawback as of mechanical instrument, because these electrical instruments are also using pointer which is having mass associated with it. So again, these kind of instruments are not good for dynamic response measurement. They are also having a limited time response. That means whenever we are having quantity which is available for very less time, so they may not be able to sense that quantity. That is a problem with electrical instruments. With advancement of science and technology, we are having various phenomena that are having various variables that may appear for very less period of time, like they may appear for in milliseconds or microseconds or even nanoseconds. So that kind of a small response we cannot measure using electrical and mechanical instrument. So for that we are having electronics instrument that can sense a quantity which is having very small time response. Earlier, electronic instruments are built using vacuum tubes, but vacuum tubes have their own disadvantage, like they are bulky in size, and also with the flow of electrons they get heated up, and because of that they may fail. So now with the advancement in technology, we are having now semiconductor materials that are used for making of electronic devices. Here we are having an oscilloscope. It is an electronic device, and oscilloscope can measure a response of in nanoseconds. So that is the biggest advantage with the electronic device, that we can measure a very weak signal. And also one of the biggest advantage with electronic device is that whatever weak signal that we are going to measure, we can amplify them and we can use them to actuate any actuator. And also electronic instruments are compact in size and they are going to offer us high degree of reliability. Additionally, power consumption by electronic device is very low as compared to other devices that we are having. Now we'll move to active and passive type of instruments. Passive instruments are the instruments that are going to give us output which is produced entirely by the quantity that we are going to measure. So whatever output that we are going to get, it will be directly based on the input quantity. So we are not going to apply any kind of external power source to measure that output. For example, here we are having a pressure gauge which is used to measure the liquid pressure that we are having here. For that we are having this piston which is connected with this spring, and this entire thing is connected with this pointer which is pivoted here. Now as the pressure of the liquid increases, what is going to happen? This piston is going to move up, compressing this spring, and also based on the pressure it is also going to deflect this pointer. So what we can do, we can directly get the pressure in the form of deflection of this pointer that we can measure by using this scale. So here whatever output we are getting because of the input itself. So we are not applying any kind of external power to read this output. Directly based on the deflection of the pointer, we are getting the output. Now when we talk about the active instrument, in order to read the output, we need to supply external power. For example, this liquid level indicator, we are having a liquid which is filled inside this container. We are having a float here which is pivoted at this point, and also we are having a pointer. So now as the liquid level goes up or down, this float is going to move up or down, moving this pointer. Now this pointer, here we are not having any scale. If we are having any scale and directly we can measure, so it will become a passive instrument. But what we are doing, we are converting this pointer deflection in the form of electrical output by attaching this external power. So what is happening? It may be a potentiometer that is producing that electrical output based on the movement of this pointer. So in order to read the output of this system, okay, or the level of the system, what we are doing, we are supplying or we are adding this electrical supply to it, and that output is getting converted into in an electrical form that we are reading. So if we are adding any kind of external power to our measuring instrument in order to read the output, then that instrument will become an active instrument. Next is analog and digital instrument. So analog instruments are going to give us continuous output, and that output, if I take, or that output if we take in a given range, it will be always infinite. Most of the instruments that are available are analog in nature. They always going to read the input and are going to give us output as a continuous signal. Similarly, we can also have a digital instrument that are going to give us output in the form of discrete steps. And if we take inner range, if we talk about so if we take inner range, so it will be having a finite different values. For example, if I'm having an analog instrument, its output will be of this nature. It will be continuous. It may be, you can have a response which may be continuously increasing or it may be continuously decreasing, but it will be always continuous. So response from analog instrument will be always a continuous output. But with digital instrument, you will be always having this kind of a discrete steps. This kind of discrete steps. Most of the instruments that are available are analog in nature, and we know that we have to use instrument for control purpose also. So in that case, they have to interact with digital computer or controllers. So for that case, we need to always convert this continuous signal in the form of these discrete steps. Okay, these discrete steps can be directly sent to computer for further processing. So in that case, we will be using an analog to digital converter. Next, we are having primary and secondary instrument. Primary instrument. So whenever we use primary instrument to measure the magnitude of quantity that we want to measure, so it always going to give us some physical constant. It is not going to give us directly an output in the form of input. Like this tangent galvanometer. We know that we use tangent galvanometer in laboratories for measurement of current, and we also aware of that current in this galvanometer will be proportional to tan of theta, and this theta is the deflection of the needle that we are having inside this galvanometer. So whenever we try to measure the current in a given circuit with the galvanometer, it is not going to give us directly I value. So with the help of this pointer, we are not going to say the value of I. What we are going to get is the value of theta. So what we need to do, we need to substitute that theta value here and multiply with the constant to get the value of I. With primary instrument, the quantity that we are going to measure, we always get an output in the form of some constant. So we need to put it in the relation to get the actual output. Now with secondary instrument, we can directly measure the quantity that we are interested in, like wattmeter. So if you connect wattmeter to the circuit, directly whatever indication we will be going to get from this pointer is the value of power. So in primary instrument, whatever input quantity that we are going to measure, it will be indicated in terms of some physical constant. So we need to always know the relation between that constant and the quantity that we are trying to measure. So substitute that constant value and get the answer. And in secondary instrument, directly by connecting the instrument, we are going to get the output. Next is monitoring and control instruments. Monitoring instruments are going to give us indication, or they are just going to show us the value of the parameter that we are studying. For example, this ammeter, if we connect ammeter to the circuit, so the current that is going to flow through that circuit will be displayed to us by this pointer that we are having here. But we cannot use the information from this pointer for any other purpose. So if we are having an instrument that is just indicating us the quantity that we want to measure, will be a monitoring type of instrument. Similarly, we can have an instrument that can measure the quantity, and that measure quantity we can use for control purpose. So those kind of instruments are called as control instruments. For example, we can find this temperature sensor, that is thermistor, in air conditioner, and we know that we can set temperature in our air conditioner to certain value. Once that value is reached, this temperature will be monitored by this thermistor. Once that value is reached, the information by this sensor will be sent to controller, and then controller will going to switch off that power supply so that our room will be maintained at 20 degree. Now once the temperature is start rising, again it will be continuously monitored by this temperature sensor, and once it is reached to certain value, again that information will be sent to controller, and controller will again going to restart our air conditioner so that again the required temperature will be maintained in that room. So with this we'll end this lecture. See you in the next one.